Hello and welcome to Stories of Science. Here, we look back on humanity's long journey to understand the world. The questions, the failures, and the breakthroughs that slowly changed how we see the universe and ourselves. We tell science as stories. The question that saved the sky. Have you ever stopped and wondered, what if we almost broke the sky? Not as a metaphor. I mean, actually broke it. Because here's the unsettling part: if history had taken just a slightly different turn, if one person had not asked one simple question, then stepping outside into the sun today wouldn't feel like getting some sunshine. It would feel like slow, invisible damage. UV radiation would be stronger, a skin cancer, far more common, crops scorched before they even grow. The earth would look the same blue skies, same sunlight. But the invisible shield protecting all life, it would be punctured. And here's the twist that sounds almost absurd. This global threat didn't start with bombs, not war, not nuclear tests. It started with refrigerators. Yes, your kitchen fridge, that quiet, helpful machine keeping your ice cream frozen. And air conditioners, the thing you rely on every summer, cooling you down, while possibly releasing something dangerous into the sky. Sounds like science fiction, right? It isn't. And the person who uncovered this didn't look like a hero at all. No cape. No dramatic inventions. Just a scientist who did one simple thing. He asked a question. His name was Mario Molina. And the question? What happens to these gases after we release them? At first, it sounds almost trivial, like asking where does the air from your AC actually go? Most people would shrug, maybe laugh, then scroll on with their lives. But he didn't. He kept going. And if they do rise into the atmosphere, what happens then? That question was like dropping a stone into still water. At first, just ripples, nothing dramatic, nothing urgent. After all, we were talking about CFCs, chlorofluorocarbons. At the time, they were considered perfect. Stable. Non-toxic. Non-flammable, almost chemically boring. The kind of molecule you trust. So we used them everywhere: fridges, air conditioners, spray cans. Humanity loves obedient things. But here's the catch. Sometimes, what looks harmless is just something we don't understand yet. And Molina, he didn't trust perfection. He looked at these gases the way a detective looks at a flawless alibi. Too clean, too perfect, which makes it suspicious. So he followed their trail. From the ground, upward, through the lower atmosphere, into the stratosphere. And there, something crucial was waiting. Something you never see, but that protects you every second of every day. The ozone layer. Thin, almost unbelievably thin, yet vital, beyond imagination. And Molina had a feeling. This harmless gas might not be so harmless after all. And if he was right, this wouldn't just be a scientific curiosity. It would be a global crisis. But at the time, no panic. No headlines. No urgency. Honestly, no one really listened. Because who would believe that a scientist studying refrigerator gases could threaten the entire sky? And yet, history has a pattern. The most dangerous moments often hide inside the most ordinary questions. But Molina's story didn't start in a high-tech lab. It started somewhere far less expected. A bathroom. No metaphor. An actual bathroom. Let's rewind to the 1940s. Mexico City. A normal family, and a not-so-normal kid. Mario Molina. While other kids played with toys, he was busy asking, how does the world work? Sounds philosophical. But his approach, not philosophical at all. He didn't just think, he experimented. He turned his family's bathroom into a laboratory. Yes, really. Tile walls, running water, and a collection of chemical substances. A perfect setup. Most people go to the bathroom to get clean. He went there to create unknown gases. Picture this. A family member walks in ready for a shower, and is greeted by a strange smell, and the faint possibility of something exploding. Can we use the bathroom today? Probably not. Because Mario was busy exploring the universe. Sometimes it was gases, sometimes reactions, sometimes small explosions. Not huge, but memorable enough that his family never forgot. Was he a troublemaker? In a way, yes. But the kind of troublemaker who grows up to win a Nobel Prize. His father was a diplomat, and that mattered, because it meant young Mario was exposed to the world early. Different languages, different cultures. While most kids were asking, "What's for dinner?" he was wondering, "What don't I understand yet about the world?" Curiosity, for him, wasn't a hobby. It was instinct, and not the kind you can turn off. He didn't just want answers. He wanted to create them. That's why the bathroom became a lab, why the house sometimes smelled like chemistry, and why this ordinary kid was quietly becoming a dangerous kind of scientist. Dangerous not because he wanted destruction, but because he asked questions. The kind of questions most people don't bother asking. But soon, he hit his first real obstacle. Not equipment, not money. Language. He wanted to understand the world. But the instruction manual of science at the time, it was written in German. So the story takes a turn. To do science, he first had to learn survival. 1960s. Switzerland. A young Mario Molina arrives, armed with curiosity and a lot of confusion, ready to dive into science. But the first challenge? Language. At the time, chemistry wasn't just about experiments. It was about reading papers, textbooks, discussions, and a huge part of it was in German. You think science is hard? Try understanding it when you can't even read the words. It's like finally getting a treasure map only to realize it's written in symbols you don't understand. So he learned. Not for fun, for survival. Because if you can't understand what others have discovered, how can you discover anything yourself? In class, others nodded along. He translated in his head. The professor spoke one sentence, he understood half. The rest, guessed. And then there was the culture shock. Different food, different pace, different humor. At times, he must have wondered, am I here to study chemistry, or to learn how to survive? But he didn't quit, because he knew. This was the gate. Cross it, and the world opens. Slowly, things changed. Strange words became familiar, unreadable papers began to make sense. For the first time, he could read science. Not secondhand, not explained by others, but directly. And that moment? It mattered. Because from then on, he wasn't just a curious mind. He was becoming a real scientist. But understanding the world was only step one. Next, he would have to question it. At the University of California, Berkeley, something shifted. The air there, yeah, it was free, but it also carried a hint of danger. Late 1960s. Mario Molina walks into the lab thinking he knows what's coming: clean reactions, precise data, maybe a respectable paper or two. Science as usual. Instead, lasers. Not the concert kind, of the kind that can rip molecules apart. Welcome to laser chemistry. And honestly, it was cool. You could control molecules, steer reactions, even design outcomes. Like building with Lego, except the bricks are atoms. But then something clicked. This power wasn't just for discovery. It could be used for something else. Something less innocent. Military applications. You start out wanting to understand molecules, and suddenly realize your work could be used to build weapons. That moment? The lab lights are still on, everything looks the same. But inside something dims. Because science, all of a sudden, isn't neutral anymore. It has direction, consequences. A price tag. He began to understand. Science isn't just a playground for the curious. It's a knife. You can use it to slice fruit, or something far more dangerous. And quietly, a new question appeared. Not in his notebook. In his mind. It shifted from "Can I do this?" to something heavier. Should I? No fireworks. No dramatic turning point. Just a quiet pivot. But deep. From then on, Molina wasn't just chasing discovery. He started thinking about impact. And that shift? It would change everything. Not just for him, but for the entire planet. Fast forward to 1973. Looks like any ordinary year. But for Molina? This is where things get interesting. Because this is when he meets F. Sherwood Rowland. Now, if Molina is the guy who asks strange questions, Rowland is the one who takes them seriously. They clicked instantly, like two radios suddenly tuned to the same frequency. And they decided to study something almost nobody was worried about: CFCs, chlorofluorocarbons. Awkward name of familiar presence. Fridges, air conditioners, spray cans. Everywhere. And the scientific consensus? Almost laughably simple. Stable, safe, harmless, basically perfect. The kind of thing the whole world agrees on with absolute confidence. No problem here. But here's where things get interesting. If something truly doesn't react, doesn't break down, doesn't disappear, then where does it go? It doesn't vanish. So what is it doing? Floating around aimlessly, waiting its turn? It sounds like a boring question, like asking if trash doesn't decompose, does it just pile up? Most people wouldn't lose sleep over it. But they didn't laugh. They leaned in. They calculated, modeled, worked step by step, like tracking an invisible fugitive. These molecules slowly rising, past the troposphere into the stratosphere, higher and higher, where sunlight gets harsher, where ultraviolet radiation gets serious. And up there, those stable molecules stop being so stable. That's when things started to feel off. Not slightly off, deeply off. They began to see a possibility, the kind you hope is wrong, because if it's right, then these gases we casually release every day are quietly doing something dangerous. Very dangerous. It's funny how it works sometimes. The thing that ends the world is the wrong answer. It's the question nobody bothered to ask. 1973 to 1974. No explosions in the lab. No alarms. Just paper, pens, and calculations that look painfully boring. Molina and Rowland started doing something slow. Tracking gases. Not with their eyes, with math. CFC molecules leak from fridges, escape from spray cans, adrift out of air conditioners. They're light. So light that they rise. Not in a day, not in a week. Over years, decades. Like travelers with no destination. Slowly, they leave the ground behind. Layer by layer. Troposphere, stratosphere. The work itself? Tedious. No music. No montage. Just someone staring at equations until suddenly. Wait. Because the numbers start acting strange. Down here, these molecules are calm, stable, predictable. Model citizens. But up there? Different story. Because in the stratosphere, there's something you don't feel down here. Ultraviolet radiation. Sunlight's hidden mode. At ground level, it's filtered. Up there, it's intense. Strong enough to break molecules apart. So they ran the numbers. A UV photon hits a CFC molecule. Snap. It splits, releasing something small. A chlorine atom. Doesn't sound like much, right? But here's the problem. It's reactive. Not let's chat reactive, more like let's wreck things reactive. They kept going. One chlorine atom meets one ozone molecule. Reaction. Ozone breaks apart, turns into ordinary oxygen. Protection reduced. But here's the real problem. That chlorine atom doesn't get used up. It moves on. Finds another ozone molecule. Breaks that one too. Then another, and another. Like a machine that doesn't stop. They ran the estimates. One chlorine atom could destroy tens of thousands of ozone molecules. At this point, things get quiet. Not because they're done. Because they're not sure they want to keep going. But they do. Because that's the job. If global CFC emissions continue, if these molecules keep rising, if they keep breaking apart, what does that mean? They plug everything in. Variables. Models. Assumptions. Step by step. No dramatic soundtrack. But your pulse starts to pick up. Because the answer is forming. Not suddenly. But like a slow realization, you already know it's bad. You just haven't faced how bad yet. And when the final line is written, no celebration, no high fives, no we did it. Just silence. Because they've found something that doesn't let you sleep. Here's the part most people don't realize. The sky isn't just blue. It's protected. That blue you see every day, it's not just color. It's the result of something working. Something invisible. The ozone layer. Thin, almost unbelievably thin. If you shrank Earth down, it would be like a coating just a few millimeters thick. Sounds fragile. Because it is. But it blocks the most dangerous part of sunlight: ultraviolet radiation. Without it, sunlight isn't warmth. It's attack. First your skin, then plants, then entire ecosystems. The Earth wouldn't explode overnight. It would just slowly become unlivable. And what Molina and Roland realized was this: that shield is being eaten away. Not all at once, piece by piece. Silently, they connected the dots. CFCs rise or reach the stratosphere, get hit by UV, break apart, release chlorine. And then the real story begins. That chlorine atom? It doesn't rest, doesn't stop, doesn't clock out. It just keeps going. Finds ozone, breaks it, moves on. Again. A loop with no natural end. Because it isn't consumed. This isn't just a reaction. It's catalytic. In plain English, the worker never gets tired. So they asked the bigger question: how much damage can one chlorine atom do? The answer? Tens of thousands. 1 to 10,000. If this were a workplace, the boss would be thrilled. But here, the job is dismantling Earth's shield. And it's not just one chlorine atom. It's millions, billions. Because CFCs are still being released. Fridges running, AC units cooling, a spray can spraying. Every day, humanity adds more fuel to the process. So this isn't a one-time event. It's a chain reaction. Like dominoes. Once it starts, it keeps going. They realized this wasn't ordinary pollution. Not the air feels dirty. Not visibility is low. This is systemic. The kind of problem that changes the entire state of the planet. They could even see the future. Less ozone, more UV, higher cancer rates, ecosystems destabilizing. And the scariest part? It happens slowly. No explosion, no alarm. You don't notice it right away. Because it creeps. So slowly that you think everything's fine. Until decades later, nothing is. They sat there, looking at the conclusion. It didn't feel real. Like solving an equation and getting, the world might be in trouble. What do? You check again. They did. Recalculated, verified, changed methods, built new models. Same result. Clearer each time. At that point, the question isn't, is this correct? It becomes, if this is correct, what do we do? So they did what scientists do. They wrote the paper, organized the data, built the model, or presented the conclusion. Calm, rational, scientific. 1974. They submitted it. The message was simple. Human-made CFCs may be destroying the ozone layer. If it doesn't stop, the consequences will be severe. They hit send. They probably expected debate, maybe skepticism. What they didn't expect was this: the world was about to explode. The moment you threaten an entire industry, you stop being just a scientist. You become a problem. After 1974, the paper by Mario Molina and F. Sherwood Rowland didn't just make a splash. It hit like a stone dropped into a lake worth billions. And this wasn't ripples. This was waves. The first to react, industry. The companies producing CFCs looked at the research and thought one thing: this can't stand. Not because the data was weak, but because the conclusion was inconvenient. Because if it was true, everything changes. Refrigerators? Redesign them. Air conditioners? Rethink them. Aerosols? Rebuild from scratch. An entire global system needs surgery. And surgery at that scale costs a fortune. So the pushback began. The evidence isn't strong enough. The model is too simple. We need more research. Which, translated into plain English, sounds like, don't touch our business. Then the media stepped in. Headlines got louder, more dramatic. Scientists say the air is toxic. Is your fridge destroying the planet? Sounds like sci-fi. Or exaggeration. And the public? Confused. Because from their perspective, my fridge has worked fine for 10 years. The sky hasn't fallen. Fair point. Very fair. Because this is what makes the problem so dangerous. It doesn't hit all at once. It creeps. so slowly that it feels unreal. Like the old saying goes, a washed pot never boils, but that doesn't mean the water isn't heating. Governments? They hesitated. Because they had to balance everything: science, economy, jobs. You don't shut down an entire industry based on a theory. That has consequences too. So the official line became: more research is needed. Sounds reasonable. Sounds calm. But sometimes, let's study it further really means, let's wait. And during that waiting period, Molina and his colleagues found themselves in a strange place. Not ignored. Observed. Some supported them, some questioned them, some pushed back hard. And a few quietly suggested, maybe you're exaggerating. Imagine that feeling. You discover something serious, you speak up, and the world responds with, let's see. Or worse, are you just trying to get attention? It's almost funny. Almost. But more like the kind of joke that doesn't make you laugh. Still, they didn't back down. They kept explaining, clarifying, or repeating the same uncomfortable conclusion. Because they understood something simple. If you don't talk about the problem, it doesn't disappear. It grows. Time passed. The 1970s faded, the 1980s began. The debate dragged on like a tug-of-war. Data on one side, interests on the other. Who wins? At the time, nobody knew. Until 1985. That's when scientists working in Antarctica noticed something strange. Ozone levels dropping. Not slightly. Dramatically. At first, they thought the instruments were broken. So they checked them. Again, same result. Checked again. Still the same. At some point, the realization hits. It's not the equipment. It's real. Later, this phenomenon got a name. The ozone hole. Sounds like a literal hole in the sky. It's not. It's a massive region where the ozone layer has thinned drastically. And the location? Antarctica. Cold is stable, the perfect environment for those chemical reactions to run wild. When the data went public, the world went quiet. That kind of quiet where people think, wait, this might actually be real. Because this time it wasn't theory. Not a model, not a prediction. Observation. Reality. And just like that, those calculations Molina and Rowland made years earlier stopped being hypothetical. They became something else. A prediction that came true. And now, the question had changed. It was no longer, are they right? It became, if they're right, what do we do? History shows something interesting. Humanity rarely moves together. Unless things are about to go very wrong. After 1985, the ozone issue stopped being a niche scientific topic. It became news, meetings, pressure. Countries began to realize, this isn't local, it's global. You spray something in one hemisphere and it can affect the other side of the planet. Sounds absurd, but the atmosphere doesn't care about borders. It follows physics. So something unusual happened. Scientists, governments, industries, all sat at the same table. You can imagine the mood. Tense. A little awkward. Because just a few years earlier, people were still arguing, is this even a problem? Now the conversation had shifted to, this is the problem. 1987. A turning point. In Montreal, countries signed a document. Simple name, a heavy impact. The Montreal Protocol. In plain terms, we stop. Together. Stop what? CFCs. Those perfect, harmless chemicals now officially the problem. Getting there wasn't easy. You needed agreement between nations. Buy-in from industries. A path for developing countries. Behind that one decision were endless negotiations. Compromises. Late-night discussions. You can picture it. We've already invested billions. We're still developing, we can't stop overnight. And by the way, who said this stuff was safe to begin with? Silence hangs in the room. But this time no one says, let's wait. Because they've already seen the outcome. So humanity did something rare. It acted. Production reduced, usage limited. Phase-out began. Simple in theory. Hard in reality. This wasn't flipping a switch. It was rewriting an entire industry. New technologies for refrigeration, new cooling systems, and new aerosol designs. Expensive, difficult, and full of resistance. But this time the direction held. You could say something clicked. We argue about almost everything. But when the question becomes, can we keep living like this? People get surprisingly rational, almost coordinated, like a group that argues all the time until the house catches fire. Then suddenly everyone grabs water. No debates. No ego. Just action. Years passed. Then decades. The data began to change. CFC levels down, chlorine levels down, and the ozone layer? It stopped getting worse. Then slowly, very slowly, it began to heal. Not overnight, not dramatically, but steadily, quietly, real. Scientists watched those curves and finally exhaled. Not because the problem was gone, but because, for once, we were moving in the right direction. And if you look at the data today, you'll notice something remarkable. This doesn't happen often. Humanity finds a problem, admits it, and actually fixes it before it's too late, before it becomes irreversible. We hit the brakes just in time. That's rare. And it matters. Because the story didn't start with a government policy or a corporate decision. It started with a question that once felt unnecessary. And today, the sky is still there. Still blue, still quiet. But what really changed isn't just the ozone layer. It's us. Because as the saying goes, an ounce of prevention is worth a pound of cure. And this time, we actually listened. Before him, the job description for a scientist was pretty simple. You discover something, you write it up, you publish the conclusion, then you hand the problem over to the world. What happens next? Not your department. But after Mario Molina, that line didn't just blur. It broke. Because this time, the discovery itself was powerful enough to change the rules. After the ozone crisis, science stopped being just a way to explain the world. It became a way to help decide what happens next. Governments started to realize something uncomfortable. Some problems don't wait for debates to finish. You don't get to argue forever. At some point, you have to listen to the science and act. So a new role quietly emerged. Scientists weren't just researchers anymore. They became advisors, guides, sometimes even early warning systems. Molina stepped into that space, out of the lab and into the room where decisions get made. He started weighing in on air quality, environmental policy, global cooperation. Things that used to live in academic papers begin turning into laws, standards or regulations. Real-world action. Fast forward a few decades. Now we're in the 21st century. During the presidency of Barack Obama, Molina became one of the key scientific voices in the room. And the conversation had grown. It wasn't just about one chemical anymore. It was about the entire system. Climate, energy, pollution. The scale had changed. Here's the difference. Before, a scientist might say, "There's a problem here." Now, they say, "There's a problem and here's what we should do." And sometimes they add, "If we wait, it gets worse." That's not overstepping. That's reality forcing an upgrade. Because some problems don't come with a middle option. You either deal with them now or pay for them later. Usually with interest. As the saying goes, a stitch in time saves 9. Molina was the kind of person who kept pointing that out, even when people didn't want to hear it. But his story doesn't end there. Because for him, saving the world once was the finish line. If anything, it unlocked the next level. Because once you've seen one hidden problem up close, you can't unsee the others. He didn't retire to a beach. Didn't step away for a quiet life. He shifted focus. Bigger challenges, more complicated ones. Climate change, urban pollution. Problems that move slower, hide better, and are much harder to fix. And he kept going. Researching, speaking, warning. For most people, retirement is the end of a chapter. For him, it felt more like finishing level 1 and looking up to see level 2 harder. Now think back to where this all started. We almost broke the sky. Not metaphorically, literally. We came close to a world where stepping outside might mean checking not just the weather, but how dangerous the sunlight is. A world where sunshine isn't comforting, it's harmful. And the person who helped pull us back from that edge? Not a superhero, not a politician, not even, at the beginning, someone trying to save the world. Mario Molina started somewhere much smaller. A kid doing odd little experiments in a bathroom. A student far from home, struggling through dense papers. A researcher in a lab, slowly realizing the numbers didn't look good. Nothing dramatic. No lightning bolt moment. No big red button that changes everything. He just asked one extra question. When everyone else assumed things were fine, he paused and wondered, "Are we sure?" That's it. That one question cracked everything open. Because imagine if he hadn't asked. Or if he had asked but dropped it. Or if, after the criticism, he decided, not worth it. The world today might look the same on the surface, but quietly it would be very different. And we might not even notice right away. That's the scary part. Problems don't always explode. More often, they creep in. Slowly. So slowly that you get used to them. So slowly that they start to feel normal. Which means the real turning point is how clever the answer is. It's whether anyone is willing to stop in a moment that feels perfectly normal and question it, to take a second look, to ask again. Science isn't just about equations or instruments. At its core, it's curiosity, a bit of doubt, that quiet feeling of, something about this doesn't sit right. That's what Molina followed. He didn't rewrite the laws of physics. Didn't discover a new element. He noticed something that didn't add up, and refused to ignore it. And now, the sky is still blue, the sunlight still feels warm. Everything looks normal. But now you know, that normal wasn't guaranteed. It was protected. And it's fragile. Maybe the next world-changing problem is already out there. Sitting quietly, looking unimportant, maybe even a little boring. Just waiting for someone to take it seriously and ask, is this actually safe? Because in the end, what changes the world isn't just answers. It's the courage to ask the question, and the question he asked helped save all of us. The people who change the world usually just think one step deeper. If this story made you see things differently, hit like, subscribe, and save it. See you in the next story.